Okay, hi guys. So we had a meeting yesterday, and one thing they told us is we shouldn't be going over new content at this point because the days right now technically are not counting. But the rumor is that the Michigan State Legislature will change that, and that these days will count towards your 180 days. But as of right now, they don't. So we're not allowed to. They don't want us going over new content. So what we're going to do is we're going to go back and we're going to look at the first two units of the semester, the quadrilaterals unit and the similar figures unit. And we're going to go through those again. This way, we'll basically review them so we don't have to review them for the final. Um, and if you struggle through it, you'll have the opportunity to do a retake um, to greatly improve your grade. All right, so let's go through quadrilaterals. We're going to start with parallelograms. So if we recall, quadrilaterals were polygons that had four sides. And then we had that cheat sheet with the 7 different types of special quadrilaterals. And the first was parallelograms. So today we're going to go through parallelograms. Okay, so a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So we have a quadrilateral here. And if it's a parallelogram, the opposite sides are going to be parallel. So QR is going to be parallel to PS, and OP is going to be parallel to RS. Two pairs of opposite sides parallel. Okay, that's all there is for the definition of a parallelogram. Two pairs of opposite sides are parallel. Okay, and then if you recall on the cheat sheet we had, that went through all the properties. There were 5 for parallelograms. The first property was simply the definition. Okay, it was simply that you have two pairs of opposite sides parallel, and then there were 4 other properties that we could use once we knew we had two pairs of opposite sides that were parallel. Okay, the first here is our first theorem. Okay, it says theorem 6.2 here. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So if we have a parallelogram, we know opposite sides are congruent. And that just means the lengths of the opposite sides are going to be equal. So if we look at our example 1 here, we have parallelogram FGHJ, FGHJ, and it tells us to find JH and FJ. So FG and JH are opposite sides, and since it's a parallelogram, we know opposite sides are congruent, so their lengths are equal. So JH is going to be 5. Okay, and then HG and JF are opposite sides, so that's going to be 3. Okay, so JH is going to be 5 and JF is going to be 3. That's that's just as easy as it gets. Opposite sides are congruent if you have a parallelogram. They're same size. Okay, so then we have a little problem here. ABCD, so quadrilateral ABCD is a parallelogram, and we want to find AB and AD. So we simply take opposite sides and set them equal. So AB is going to be 9, and then AD is going to be 8. All right. Theorem 6.3 and 6.4. So these have to do with the angles. So opposite angles are going to be congruent, and consecutive angles in a parallelogram are going to be supplementary. So if we look at 6.3 here, it says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So opposite angles are the ones that are across from each other. So Q here and S are opposite, right? They're across from each other. Okay, and then P and R are opposite angles. So P and R are going to be congruent, and then Q and S are going to be congruent because opposite angles in a parallelogram are congruent. And then theorem 6.4 here, it says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So the consecutive angles were the ones that were right next to each other. So Q and PR, okay, those are consecutive. So there's a supplementary. So those two angles are going to add up to 180. Okay, we also know that Q and P are consecutive angles. They're next to each other, so they add up to 180. Right there, same side interior angles, so we know they're supplementary. And again, you can do S and P. Oops. Okay, you can do S and P are consecutive. they add up to 180, they're next to each other, you can do S and R. Okay, those are going to be supplementary, they're consecutive, they're next to each other. Okay, so let's look at the example problem, going over that. So we want to find the measures of parallelograms here. So the easiest one here is R, because they're opposite, and we know opposite angles are congruent. So 70 and 70. They're across from each other, so they're 70 and 70. And then we know P and Q are consecutive. They're next to each other, so they're supplementary. They add up to 180. So we can do 180 minus 70, and that's going to give us 110. Okay, so 110 here, and then opposite are congruent. So we also have 110 down here for the measure of angle S. Okay, so the measure of angle Q is 110. Right, the measure of angle P and R were 70. And then we had Q was also, Q and S were also 110. Okay. Both of these were 70 because they were opposite, right? And then S and Q are opposite, so those are congruent. Opposite congruent, consecutive add up to 180. The ones that are next to each other add up to 180. The ones across from each other are congruent. All right, that's already 3 of our 4 properties, but they do have an example problem for us, so let's fill in the missing angles. So across from A is C, so that's going to be 60. Okay, and then these are consecutive, so if we do 180 minus 60, we're going to have 120. So these are going to be 120, and then across from it is B, so that's also 120. Okay, across from D is B, so that's also going to be 105. Okay, and then we can do 180 minus 105, and that's going to give us 75. So C is 75, A is also 75. All right, that's 3 of the 4 properties, and the last one is just about the same or as easy, I guess, as the first one, except this one we're going to say the diagonals bisect each other. So if a quadrilateral is a parallelogram, then its diagonals bisect each other. So the diagonals are the pieces that go from one corner to the other. So PR is a diagonal and QS are diagonals. Okay, and it says that those diagonals bisect each other. That means they cut each other in half. So QS is going to cut PR into half. It's going to cut it into 2 equal pieces. Okay, and then PR is going to split QS in half. It's going to cut it into 2 equal pieces. So QM is congruent to MS, and PM is congruent to MR. Okay, so if we have parallelogram here, if we have quadrilateral TUVW is a parallelogram, we know that UX is going to be congruent to XW, and we know that TX is going to be congruent to VX, right? These 2 pieces are congruent. Let me do it in color, I guess. Let's use green. This piece, right, is congruent to this piece. And then this piece here is congruent to this piece here. Okay, so if we're looking for XT, it's going to be 3, right? This piece over here, let me erase all this. It's hard to write it. I should have zoomed in probably. Okay, if that piece is 3, this piece right here is also 3. Okay. All right. And then they simply give us a recap of the properties here. So there's your definition. Okay, 2 pairs of opposite sides parallel. and there are your four properties that you're looking at. So opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Those are your four properties for parallelograms. Okay. And we'll do another screencast for going over the practice.